Hello, hi, this is Rani Ahmed with you, and this is lesson 17, how to program using Haskell programming language. And this lesson we're going to talk about control structures. Now, in this lesson we're going to talk about more if statements, case statements, all those statements that control the flow of the input into the code. Okay, and what will happen if I do this? What will happen if I don't do this? You know, things like that. So we have had a quick example on if statements, but now I'm going to use this if statement as if it's a function here. Okay, so if you notice here, I know it's easy to read, doesn't need any explanation, but from programming wise, it's good to know. So here, if I'm dealing with it as a function, okay, and together here, okay, until here, this is like the result of the if statement multiplied by y. Okay, so if I input x to the function g, okay, and it was 0, okay, then I should return 1. Why? Because I can't divide the trigonometric function of sine of x, okay, over x when x is 0. You can't divide by 0 here. Okay, so otherwise, if we input anything else other than 0, just do the division here. Okay, it's a normal double floating number value, you know. So this is one of the ways to use if statement quickly. Okay, now another thing is we had the way of writing that I have some fixed points for the function and they are well known, like f of 0 is 18, f of 1 is 15, f of 2 is 12, and f of x, whichever x is, okay, or whatever x is, it will be 12 minus x. Okay, but this is exactly equivalent to having the function of case, which is very much like using the case statement of Haskell or the switch statement of Haskell, okay, of Java and C. Okay, so for example, I'm saying here that for the same values on f, I just renamed it just to make it get it compiled. So z of x, okay, is the function of case of x of, if I have 0, I will get 18. If I have 1, I will get 15. If I have 2, it will give me 12. So the arrow here is like give me, okay? It gives me the output of, okay? And you know, the underscore will be whatever. Okay, so by pattern matching x, if you want, you can put x here. I'm not saying you can, okay? It's like you're putting x here and to give 12 minus x. Cool? This is one of the ways that you can use case. Now, another way of using case is, let's imagine that I have a data type called color, and it gives me the constructors of a black color, white color, and any other color using the three integer numbers. The first integer number represents the red, okay, color. I mean, how bright is that red, okay, and how bright is that green, and how bright or dim this blue. Okay, the mixture of those three numbers, okay, can give you the color that you want. Maybe you can get a velvet or violet, you know, or maybe some yellow. Okay, those you can't get unless you mix the R and G and B. Okay, there are other ways of getting colors also, okay, but this is one of the most famous ones. Okay, now I want to make a function that describes black or white, so it takes a color. It does not take, you know, the usual what do you call them, native the string and integer and you know, the char. Okay, so those are the primitive ones. This is the word I want to say. They are the primitive data types. Now here I'm inputting a color. Okay, so I can switch on a color. I can use a case on a color. So describe black and white. Now, you know, it takes a color and gives me back a string. So just to describe what's the type of the color that I'm input. Okay, so whether it's a black or white. So when C is input, this color is, you're adding a string that describes the color. Okay, case of C of, see what's the case of C. Okay, nice words, nice rap. So black, it gives me a black string. Okay, white gives me the word white. Okay, RGB of zeros, this is by definition it's black. Okay, you know, you made everything dimmed, 0. Okay, so it will be black. So the mixture of dim, it will be 0. And the mixture of all bright, okay, 255 means the brightest ever. Okay, the brightest possible of a color, it will be white. Okay, so everything will be white. So if I use the underscore, it will be anything else. So if I have an RGB of, for example, 15, 12, 200, okay, you'll find that color. Okay, so anything else will give you the word or the sentence something else. Okay, now another way of using the case is there's a function called compare. See, I'm using it here. And there is also a data type called ordering. Okay, and compare gives me an output of ordering. Okay, and the ordering can be LT for less than, GT for greater than, and EQ for equality. I think you guessed them. Okay, now, and LT and GT and EQ are, you know, constructors. Okay, of the ordering data type. Now, here what he's doing in this function is that he's always calling do guessing, okay, on the number that I've just set inside my code. Like I start, for example, in the main function with do guessing as 100. Now, when you compile it, you give it to somebody, he doesn't know that there is 100 inside the code. So it will always call itself until you have it correctly equal to 100. Okay, see, this is a test here. Now this is just for the sine over x. Okay, just discard it. Now this is the interior guess. If I put 1, it will be too low. It will call again the function do guessing. If I put like 1000, it will be too high. Okay, put 2000, it will always say to you it's too high. But when I put 100, it will say you win and you go out of the application. Okay, or of the program. So this is do guessing. So just as you saw, it will put the word or the sentence into your guess. Here I'm reading the guess. Okay, and when I read the guess, it will compare the number that's coming from 100, okay, with the guess that has been read. Okay, so the function will do the comparison. So when it's LT, it will print the action of too low, okay, and it will call do guessing again, and so on and so on. So on the same number, of course, because you want to make sure that that number is the one you're guessing up on. You're doing the guessing on. Okay, so that's all. This is all about this control structure. Thanks for watching. Please subscribe and click the likes, click the ads, everything. Thanks for watching.